I'm fine with it.
Atharva, I cannot hear you.
Hello,
Yeah,
I'm fine with
somebody,
this time.
someone is requesting me to shift this lecture. I don't know who. You will have to give me some other slot. Tuesday. Today is what? Wednesday. Wednesday, anytime between 10 to 1, I am okay. You must be having lectures.
Ma'am,
Yes.
because the different slots of different days, there is
Yeah,
no free slot till 4 p.m. on any day.
I know.
So if there is no issue for 4 to 5 p.m., then we can shift.
Okay. Somebody raised objection for this 4 to 5 also. Can't we not shift this to some other time?
Then there is only single slot of mid break.
Yes. Okay, let me start. So if I engage your lecture in during lunch break 1 to 2, I am okay with that. When would you have your lunch? You have lectures 9 to 1, right? Okay, we'll figure out later. As of now, let's begin our.
Hello, ma'am.
Yes.
Actually, we can't shift in between mid break also. There are TNP lectures between 1 to 2. So the schedule is packed till 4.
Good. So we are okay at 8 a.m. then. We already have how many students? 78 students. If they can wake up for 8 a.m. lecture, others should also be in a position to wake up, isn't it? Why shift then? You don't have to travel anywhere physically to reach at 8. When we were having physical lectures, students used to struggle because their breakfast is served between 8 to 9. So if they had to reach at 8, then most of the time, few hostel mess which were not ready at 8, they had to skip their breakfast and then they'll directly get the lunch at 1. So that was the excuse they gave, reaching for 8 a.m. lecture. If they have to reach at 7:50, they have to start from hostel at 7:40. So this is logical, isn't it? Be you are anyway resting at home. क्या फर्क पड़ता है? Well, let's start our discussion. We were talking about this gear pair design. where we were working with this two-stage gear reduction with a motor with a set of gear P1, G1, another gear set P2, G2, and then a rotating drum using a hoist which was lifting a weight of the given magnitude. We have designed the gear P1, G1, we have designed the gear P2, G2, and what are their diameters? If you can quickly revise, yeah. So we have seen for the stage 2 with module 10, the diameter of the gear comes out to be 1420, which is the largest gear, and so this will be the heaviest of the P1, G1 and P2, G2. So we'll start with the design of shaft, which is carrying this heaviest of the gear. So this is just a representative diagram. This is not exactly what we are working with. Now this gear would be mounted on a shaft, and the shaft is supported on two bearings. We have to design this particular shaft. And we refer to the design data book to get this particular formula for getting the design torque first. Now, what is the design torque? What is the power at this shaft? If we are designing it for the power PD, which was how much? 67.5 kilowatt at the motor shaft, after reducing the efficiency, what was the power available at the next shaft? You multiply it with 98% once and 98% twice. 66 kilowatt is the power available in the gear G1 or pinion P2. We are designing the gear G2. The motor, this is the first pinion P1, gear G1. Here it is 67.5. And then here you have this pinion P2. This is the gear G2. And here you have this rotating drum lifting the load. What is the power available at this shaft? Yeah. So you multiply this 67.5, there's a 2% loss here and 2% loss here. So the power available, to be precise, at this shaft is 67.5 multiplied with 98% efficiency for P1 G1 and 98% efficiency for P2 G2, which gives you how much? 64.68. Okay. And this is rotating at what RPM? G2. Gear G2 is rotating at how much RPM? 42.2. And what is the service factor here? Refer the design data book. Page number is 109, table 11.1. The service factors are given on page 112. Load factors for various machines. Depending upon what is a driving machine and what is a driven machine. What is the driving machinery in our case? If you can access table 11.5. As per my book, it is page number 112. Electric motor is the driving machinery. And what is the driven machinery in our case? From this given list, elevator, yes. And what is the load factor value given? This is given quite high, 1.75. So this is a load factor given over there. So the value of TD further increases. Use K as 1.75 for motor elevator combination. Input is electric motor, output is elevator. It's a hoist, but elevator and hoist are almost the same. So give me what is the design torque in Newton meter. Give me what is design torque. Is it 25.4? Somebody please confirm. 25.6. Okay, let's go with this. I'm taking 25.5. This is in kilonewton, right? Newton meter. Abhi, what next? This is a formula given for the solid shaft, which will give us the shaft diameter dq as 16 10⁻³ upon pi into tau max root over bending moment square plus this torque square. Now we have the value of TD. How to get bending moment? If you have a shaft with which is supported at these two ends with the bearing, if you know the gear, if you know its diameter, if you know its thickness, because face width is known, from the density of the material you can find out what is its weight, what is its radial load, and from here you can find out the reactions. But here, can we get the reactions at the bearings in our problem? What do we need to get the reactions? Can you give me what is the bending moment? Yes, anyone? Aditya? Nikhil?
Yes, ma'am.
How can you get the bending moment?
I have no idea.
Atul? Force and distance should be known. So all loads are known. But the force is coming, its weight that can be calculated. Distance is not known. You don't know what is the length of the shaft where the bearing is placed. So what do we do? How do we proceed then? What we do is, whenever we are designing the shaft, we are designing a pulley, we are designing a flywheel, every time you will be requiring the diameter of the shaft because we are designing all these parts individually. And in none of the cases, the length of the shaft or positions of the bearings would be known. And so, because we have to anyway solve this, we'll assume that bending moment is 0. And if this value is 0, you will have to manipulate or adjust this value of tau max also, so that the diameter is calculated only on the basis of TD. What we do is, the value of tau max is given, it should be less than 0.3 times its yield strength or 0.18 times its ultimate strength. If you refer to the earlier pages where the yield strength or the ultimate strength is given, the value of tau max will come out to be almost 70 or 75 MPa. This is roughly 75 MPa for the material that we are using, cast steel. So what we do is, because we are ignoring this, we reduce the value of tau max to 40 MPa for the material of the shaft. Normally the material of the shaft, it's given on the next page, it is SAE grade 1015, 1020, so on. And for all these materials, the value of tau max is normally given as 75 MPa. I repeat, if you are ignoring the value of M, we reduce the value of tau max also. This is to take into account the bending moment which is not considered. So for all the shaft design, whenever you are ignoring bending moment, you can directly take the value of tau max as 40 MPa. If bending moment is known, then this is the maximum shear stress it can withstand. Bending moment is not known, so we are reducing this limit of the maximum shear stress also. Is that clear what we are doing here? Yes or no? This will be into TD. Now, once we are done with individual design of components like gears, belt drive, wire rope, flywheel, bearings, end of the semester we'll be having the assembly design, wherein you will design everything: motor, shaft, bearings, flywheel, everything. And then the location of bearings would be given in the problem, or will assume suitable location. And in that particular case, you will be in a position to find out what is the bending moment. There we'll be using this value of tau max in the range of 75 to 80. I'll be asking you again why we are using tau max 40 or what is the actual value. Now give me the value of diameter of the shaft. This is diameter of the shaft. Tau max is 40 MPa, TD we have just calculated 25.45 something. Give me the shaft dia. .48 meters. Check with your units. Check the value of TD. Check the value of tau max. TD should be in newtons if you are using tau max in 40 MPa. A different length of shaft, different bending moment will be there. So which one should be considered as M? The maximum. We always design it for the maximum bending moment. You remember solid mechanics, we have drawn shear force diagram and bending moment diagram. So wherever you get the maximum bending moment, or wherever there is a change in the bending moment from positive to negative, which in this case would be definitely near the position on the shaft where gear is placed. Give me the value of diameter of the shaft. What values you are getting? 1.48 meters. Something is wrong there. वन मीटर का शाफ्ट रहेगा क्या? 1.48 meters का shaft है, diameter of your gear is 1.4, diameter of your gear is 1.41, diameter of the shaft is 1.48. D cube is this. You are taking cube root, right? Are you all getting the same answer? 1.48 meters? Or is it 0.148? Okay, try with this. We have already taken design power. So you can actually eliminate this value of service factor because now we are taking service factor twice. हमने ये design power 67.5 लिया, then also we considered the service factor. Rated motor was 45. So if you are taking the rated motor power, then use service factor. Abhi we are using service factor twice. Initially, for the design of motor and the pinion, we had taken a service factor of 1.5. If instead I don't go with this 1.75, if I simply go with 64.68, what is TD? If I'm using TD, 10.55 watt. Okay. So TD is 14.5 10 cube Newton meter. Okay. Now give me what is, with this TD, what is the value of diameter of the shaft? You are still messing up with units. The answer for this is 125 mm or 123 mm. Somewhere this 10 cube, yes, it has to be 0.125. Earlier also it was 0.14 something. Uh, what was the problem, Atul? You are getting 0.12 and Ayush, you are getting 1.2.
Ma'am, 0.147.
1/4 of what?
0.147 meter.
Yes, so how come others are getting 1.47? You have
Actually,
to
40 MPa, I took it as Newton per mm square. So it will be 40 into 10 power 6 Newton per meter square.
Yes, so there is some mistake in the conversion of units. Others, please check.
And TD is also in kilonewton now. Then it will get cancelled 10 to the power 6 by 10 to the power 6.
Kilonewton converting to Newton is 10 to the power 3, right?
Numerator it is 10 to the power 6. In denominator it is also 10 to the power 6. Then it get
In
cancelled.
numerator it is 10 to the power 3 kilonewton converted to Newton.
16 it is already 10 to the power 6.
Meter is also converted to millimeter now. So in that case, it would be 10 to the power 6 in numerator also.
And Shreya, how you are getting 148 mm? Initially you were getting, yeah.
Tau max like is megapascal is Newton per mm square, and
Yes.
then I converted TD as millimeters. I got 148.
TD as Newton millimeter.
Yes, ma'am.
So that is why it is getting cancelled. 14.5 by 40. So are you getting 148 mm now, all of you? Manas? Are you getting this value now? 148 or 125? 148 by using service factor twice. 125 by using it only once. So the logic here is if TD is calculated from design power, we have already considered rated service factor. So no need to multiply it again. And if you are working with the rated power of the motor, what was 45 kilowatt, then you'll have to multiply it once. Should we go ahead with this diameter of shaft? Yes, no. Ajinkya, Ayush, Atharv, should we proceed? Will you explain again, please? Explain what? The value of d cube should be 16 into 10 cube into 14.5 10 raised to 3 for kilonewton to Newton and 10 raised to 3 for meters to millimeters. Upon 3.14 into 40 megapascal, which happens to be Newton per mm square. Newton per megapascal is what? Newton per mm square, right? Newton per service factor is for whole mechanism, not for the individual component. This value is not this one. TD is in Newton meter, this is in megapascal, and you get diameter in mm. In this formula, if you refer to the design data book, TD is given in Newton meter Let it be in Newton meter. Tau is given in megapascals. And this 16, 10 raised to 3, this is already taking care of this value of D in mm. So it is this which should take care of your diameter in millimeter cube root of 16 into 14.5 into 10 raised to 6 upon 3.14 into 40. And this I am sure you will get 0. You will get 125, which is in mm. Are you getting it?
Yes, ma'am.
Okay, going on to the next. Now, what is the hub? Look at this figure. An armed wheel or an armed pulley or an armed gear or a flywheel with arms will look like this, which is showing only one arm. This arm will normally have an elliptical cross section. This is the diameter of the shaft, and this was the diameter of the hub. Now, this is a shaft. This I am sure you have studied in machine drawing. So, this is a shaft. This is the hub. This is giving you the length of the hub. This is the length of the arm shown in the side view. And then this is the outer diameter of the pulley or the gear wheel. This is the innermost diameter di from where the arm starts. And this is the base circle diameter of the gear. So after designing this small d, which we got as 125 mm, now we are going to design this hub. Hub diameter is given in table 11.8. Hub diameter is normally 2 times of shaft diameter, 2h. It will vary from actually 1.5h to 2h. Diameter of the hub will be 2 times of diameter of the shaft. This is given in table 11.8. So what is the diameter of hub now? To 50 mm. Next is length of the hub. Give me the length of the hub. And the same table, length of the hub is given 2 to 2.5 times d. This is ds, what we are considering as capital ds, shaft diameter. What value you want to take? A range between 2 to 2.5. You can go with 2.2, 2.3. Okay, let's go with 2.3. Give me this shaft diameter, 125. Give me length of the hub. 287. 87 mm. This is the length of the hub. You understand? This is hub and this is front view and side view of hub. Next is arms. Arms are normally of elliptical cross section as shown here. And for getting its cross section, we have to find out what is the bending moment first. for this cross section. So what would be the bending moment on the arm? Can you tell me by simple logic what is the force coming perpendicular to the arm? What is the force which is driving the gear? It is the static force Ft, which is acting at what distance? This force is normally acting at pitch circle diameter, and this is the length of the arm. So what is this total length? It is the outer diameter dp minus the hub diameter dh, the pitch circle diameter dp for the gear, minus this hub diameter dh by 2. And this bending moment is shared by how many arms? Bharti? How many arms we have considered for this diameter?
Yes, ma'am.
How many number of arms we have considered?
2.
2. The last class we were discussing about number of arms. 6. So this bending moment is shared by 6 arms. So this is the bending moment on each arm. Give me this value. Our pitch circle diameter is 1420, I guess, and diameter of the hub is 250. So this is a length of the arm which is sharing the bending moment. Give me the bending moment. Harshini gave me the answer. Ambika, FT on second gear, yes. Value of FT for second gear pair P2G2 is same. Yeah, so this is coming out to be 2100 Newton meter. Good. This is the bending moment on each arm. Now how to get the section modulus? Allowable stress is bending moment M by Z. What is the allowable stress in arms? Everything is given in this design data book. If you turn to table number 11.6, page 113, the last row is giving you allowable stresses in arms for cast iron steady load, for cast iron sudden load, and for cast steel. Our material is cast steel. What is the value of allowable stress given there? Table 11.6. Yes. Allowable stress given is 25 MPa. So give me the value of section modulus. We are trying to find out what is the cross section of the arm. M is known. Allowable stress for arms made out of cast steel. 25 MPa. 83.3 mm. Value of Z will be in mm. What will be the units for Z? Millimeter cube. So what is the unit? Is it 83 mm cube? Z. Again check your units. No. Give me the value of Z. Eight double three double zero, yes, or 8400. You are right. This is Z. Now for elliptical cross section, what is Z? For elliptical cross section, what is Z? This is our ellipse with elliptical cross section. If this is the larger of two, and B and H is half of that. What is Z for elliptical cross section? Shravya?
Ma'am, I don't know.
Saurabh?
No, ma'am, I don't.
Who is giving me the answer? Manas? It is pi b h square by 32. This Z is pi b h square by 32. Now B is normally taken as half of h, where the meaning of B and h is as given here. This thickness of arm, which is the major axis, this is h, and perpendicular to this is B. which is smaller of this. So the minor axis of this ellipse is B and the major axis is H, and the minor axis we have taken as half of this. And so this is further simplified. This comes out to be pi h cube by 64. So give me what is h? Pi h cube by 64 is 84,000. So what is h? One 9.6. So 119.6 is its major axis and its minor axis is half of this 60 roughly 59 point something. Now one last point. Again, this is very important from your gate examination or from interview point of view. Yeah, 59.8. Now there are how many arms to be placed across the periphery of the hub? 6 arms. Now we have to make sure that there is enough space for 6 arms to be placed on the periphery. What is the hub diameter? Itna hai hub diameter 250 mm. What is the circumference? What is the space available here? What is the circumference of the hub? On this circumference of the hub, we have to place 6 such arms. And this value of h is 122. So I must get 122 into 6, which should be less than the circumference of hub. This should be less. Abhi to bhi aayega, right? So what is pi into dh? This is pi into dh, Saurabh. 785. And what is 122 into 6? 732. Yes. So this is just good enough and you get enough space in between the arms. Suppose you get this value as 800. अभी हमने hub diameter twice लिया इसलिए. Sometimes for flywheel it is given only 1.5 times. If suppose this value comes out to be less, suppose this value is 800 and this value is 785, what will you do? So the space required for the base of hub is more than the hub base of the arm is more than the hub circumference. So in a lesser space, you have to fit in more number of arms. What will you do? If anybody can guess. This is again a very important concept. Reduce the number of arms. No, you cannot. You cannot. और क्या कर सकते हो? Fillets. Fillets के लिए you don't have space. Your arms are overlapping like this. ये एक arm हो गया. This is another arm. Overlap the bottom. Yes, Manas is right. Manas is right. Increase the hub diameter. Now, if I increase this hub diameter overall, the material required will be more. This is my hub. If I increase this hub diameter, now this is also giving you the answer. This is the face width of the gear. Arm is not extending throughout the width. Arm is only for this much thickness. B value we have seen and H value we have seen. This is H and B is only 59. Whereas our face width kitna aaya tha, 85, 90 something. So we will locally increase the diameter of the hub. So we are giving this kind of a local increase in the diameter of the hub, and this is known as beading. A beading is provided beading is a local increase in the hub diameter. So only exactly at the location where this is placed, we are increasing this hub diameter. So moment you increase the hub diameter, the circumference increases, and now you have enough space for all the arms to sit in there. And that increased hub diameter would be pi DHS should be equal to 6 times of your arms. So if this is coming out to be 800, then we find out the increased, suppose your 122 into 6, or suppose your H value came out to be 140. Suppose this is just for explanation. So your H into 6, the space required here will be 140 into 6, which is how much? 760. 840. So we will equate this with pi into hub diameter with beading. This 840 by pi, this will be the new beading diameter. This is a local increase. I'm showing you this figure again. This is the local increase in the diameter of the hub, and this is just to accommodate all the 6 arms. If you reduce the number of arms and the bending moment on each arm, this would increase. Here n was 6, so you got 2100. With n equal to 4, this bending moment would increase. When you increase the value of bending moment, for the same allowable stress, your Z will be larger, and Z is larger means again your B and H would increase. So your arms are too bulky. And so increasing the or reducing the number of arms is not an option. Yeah, fillets are anyway given. No, we're not designing for this fillet. And then you have a keyway design also for the given diameter of the shaft. The dimensions of key is directly given. I'm sure this part you have done in your MD1 design of key. Yes or no, Rajwal? Rajwal, have you done key design? Shravya, Ambika? I don't know why there's a delayed response on chat box today. Are you done with the hub key design? And is this beading part clear? Rushika? Arshini? Clear. Okay. And have you done this key design? No. It was in syllabus, but you are not done. So based on the diameter of the shaft, you directly get the dimensions of the key. All you have to do is cut the keyway. So next class, we are going to start with the helical gear, and the design of the shaft for the helical gear, for the hub, for the arms will remain the same. Okay, keyway I'll tell you maybe in the next class. Okay, any doubts till here? Anything related to the spur gear design? Kajal? There are no doubts, then you are free to leave. If you have any doubts, you are free to ask.